Hey guys, this is Laknara Education. In this video, we will talk about the input devices, output devices, storage devices, about the CPU and advanced computer techniques like parallel and grid computing. So let's go on. Input devices. Input devices are the tools we use to feed data into a computer. Some examples can be taken as keyboard, mouse, scanner, microphone, touchscreen, and there are so many devices. And now let us see the advantages of direct entry input devices. Direct entry devices like scanners, touchscreens, or barcode readers are beneficial because they automate the data entry process. It also reduces the human errors and speeding things up. This makes them more efficient and accurate compared to traditional devices like keyboards. Output devices. Output devices display or produce the results from the computer's processing. Some examples include monitors, printers, speakers, and projectors. These devices shows us the outcome of input and processing tasks. Monitors. When we talk about monitors, this technology has evolved quite a bit over the years. CRT monitors. They are the ones the standard and use electron beams to create images. However, they are bulky and energy consuming. On the other hand, LCD monitors are much thinner and use liquid crystals and more energy efficient. The newer LED monitors, a type of LCD, use energy efficient LED backlighting and offer better contrast and brightness, making them more popular choice today. Printers. Actually, printers come in various types, each suited for specific tasks. Dot matrix printers are impact printers that can print multi-part forms, but they are noisy and not great for high quality prints. The second one, the inkjet printer, produce high quality color prints, making them ideal for photos and images, though they can be more expensive to maintain due to ink cartridge cost. And the third one is the graphic plotter, are specialized printers used for creating detailed line drawings, making them essential in technical fields like engineering and architecture. And the fourth one, the laser printers are perfect for high-speed, high-volume printing, particularly in office environments, and they are produce sharp text quickly. And now let's talk about the CPU and its compatibility with the motherboard. Actually, CPU is the brain of the computer. It processes all the instructions and calculations, making everything work. Without the CPU, computer cannot function. So, for CPU to work properly with the motherboard, there are 4 factors needed to be checked. The first one is the socket support. The socket support is the place on the motherboard where the CPU fits. Each CPU has a specific socket type, so the motherboard must have the same socket for the CPU to fit and work. For example, Intel and AMD CPUs use different socket types. And the second one is the chipset support. The chipset on the motherboard helps the CPU talk to the other parts of the computer like the memory and storage. The motherboard's chipset must be compatible with the CPU so that everything works smoothly together. And the third one is the voltage support. Every CPU needs a certain amount of power to work, which called the voltage. The motherboard must provide enough power to the CPU. If the CPU needs too much power and the motherboard can't supply it, then the system won't work properly. And the fourth one is the BIOS support. The BIOS is like the computer setup program. It helps the motherboard and CPU to work together. Sometimes a new CPU needs an updated BIOS to work correctly with the motherboard. So it's important that the motherboard's BIOS supports the CPU. So in simple terms, to make sure your CPU works with the motherboard, you need to check that the socket fits, the chipset supports the CPU, the motherboard provides enough voltage, and the BIOS is up to date. Storage devices. Storage devices are essential for saving data permanently. Some examples for storage devices are the hard disk, the external hard disk, magnetic tape, optical drives, flash drives, and memory cards. Parallel computing. Parallel computing is a method of computing where a large task is divided into small parts and these parts worked on simultaneously by multiple processors instead of one processor doing everything one by one. This speeds up the entire process, especially when the task is very large and complex. Just imagine you have a huge task like sorting a giant list of numbers. If you try to do it by yourself, it would take a long time. But in parallel computing, this big task is broken down into small pieces and each processor handles one piece of the task at the same time, so the work gets done much faster. For example, think of it like an assembly line in a factory. If one person is making the entire product, will take a long time. But if each person on the line is responsible for just one small part, the product get made much quicker. In parallel computing, the processor are like the workers on the assembly line. Each one works on small part of the task because they are all working at once and the task is completed faster. This approach is especially useful for solving big problems that require heavy processing like weather forecasting, video rendering, or complex scientific research. These tasks need a lot of calculation and parallel computing helps speed up the process. So actually in simple terms, parallel computing allows us to take a big job breaking into small pieces and then have multiple processors to work on those pieces at the same time. This makes the whole job get done much faster than if only one processor were doing everything by itself. Grid computing. Grid computing is a way of connecting many computers to work together on a big problem. Instead of one computer doing all the work, grid computing allows many computers to share the task, making the process faster and efficient. Think of like a group of project where everyone helps with different part of the task. Each computer in grid computing works on a small part of the problem and when all the parts are combined together, the whole task gets completed quickly. For example, weather forecasting or scientific research need lot of computing power. One computer might not be strong enough, but with grid computing, many computers can work together to solve a problem faster. In short, grid computing lets many computers to work as a powerful system to solve large problems that would be too big for one computer alone. The main benefits of both parallel and grid computing or the distributed computing are their ability to process tasks faster and more cost effective by utilizing existing resources and providing flexibility as workload increases.